Morning, guys. Part 2 of lesson 2.1 is very algebraic, okay? This is solving radical equations. You're going to have to square both sides, maybe more than once. You're going to have to maybe cube both sides to get rid of a radical, whatever it is. It is not about graphing, okay? Like the first half of the lesson was. All right, so this is an example. Pretty straightforward example here. It says a radical is an equation in which the variable is in a radicand or some kind of a root here. To solve, you have to isolate, okay, that's important. Isolate the radical expression, so always get it by itself first, and then raise each side to the power that will get rid of the radical. So here we add 1 over to the other side and get 4. And then to get rid of a cube root, they cubed both sides, which made this side just x squared minus 2x plus 1, and 4 cubed is 64. So then because it had an x squared still, we needed to get it equal to 0, so we could either factor or square root or something. Use quadratic, I suppose, if we had to. So they subtracted 64 and got negative 63 over here. Then it did factor, and they got 9 or negative 7. But hugely important is checking your answer. Anytime you raise both sides to a power, there's a chance that you got an extra solution, particularly if you squared both sides. So if we plug this back in, we had 9, so we have the cubed root of 9 squared would be 81, minus 2 times 9 would be 18, plus 1, and then a minus 1 on the outside. Let me type that in on my calculator. 81 minus 18 plus 1 would be 64. So the cubed root is 64 minus 1. And remember, this was supposed to equal 3. The cubed root of 64 is 4, so 4 minus 1 does equal 3. And when we put in a 9, it checked, okay? That was our 9 that we were checking. The other possibility over here is we got a negative 7. So it says negative 7 squared. Be careful. Negative 7 squared is 49 minus 2 times negative 7 plus 1. All that's under the cubed root. And then there's a minus 1 on the outside. If we type this in, we get the square root of 64 again, which we already checked, and that does work. We get 4 minus 1 is 3. So putting in the negative 7 also checked. I will tell you if it's an odd power like a cube root, they usually both check. But you should check because you could have made an algebra mistake. All right. So is this a cubed root again? All right. So real quick, if we isolate both sides, we have the cubed root of x squared minus 1 equals 2. Then if we cube both sides, we get here the cubed root and the cubed cancel each other out. We add 1. We square root both sides, which we very carefully remember gives us a plus or minus 3. Now, both solutions will work because the first thing we're doing is squaring. So if we put either a positive or negative 3 in here, this is my check now, I will get 9 minus 1 is 8, and the cubed root of 8 is 2. Okay, and then there was on the back here a minus 6 equals negative 4. And this is true, 2 minus 6 equals negative 4. So both plus or minus 3 check. That's supposed to say 3 or negative 3. It's kind of messy. If you graphed this, I have to think about what that looks like, but anyway, you would get 2 places where it hit negative 4. I'm just going to move on here. All right, this is actually one of the easier kinds. When you have exactly one radical equal to exactly one radical, if you, in this case, square both sides because they were square roots, you get 6n minus 3 equals negative 15 plus 7n. Let's see, if I add 15 over this way and subtract 6n over this way, this gives me 12 equals 1n. So I got n is 12. If I plug it back in, now this isn't going to be pretty, but I believe it does check. If I type this in, I get 72 minus 3 is the square root of 69. And over here, I get negative 15 plus 84, which is also 69. So even though they're not nice integer answers, it does check and it's the same on both sides. So n equals 12 works. All right, number 3. This is an easy one. I just left it on here because I need you to understand that it can have a negative in the problem. When I isolate by subtracting 8, I have to still isolate, and there's like a negative 1 out here, so I need to divide both sides by negative 1. Then I have the square root of x plus 12 equals 5. If I square both sides, I get x plus 12 equals 25. I subtract and I get 13. And I plug it back up here. I get 8 minus 13 plus 12 is square root of 25. 8 minus 5 equals 3, and it checks. I know I did that one really fast, so if you need to take your time and go back over it, but it was a pretty easy one, so I didn't want to spend too much time on it. All right, this is the hardest one of all on the page. And the reason is students want to do this. Okay, don't write this down. But students want to somehow do this. Remember when we talked about a minus b squared is not the same as a squared minus b squared or a squared plus b squared? There is no distributing a power to the things inside the parentheses. The same is true here. We cannot square this by simply, we can't get rid of those squareds by simply squaring that side. It actually would look like this. Don't write this down either, because this is not what we're going to do. How's that look for a nightmare? And then you would have to FOIL all of that. Okay, what we're going to do is bad enough, but it's not that. We don't want to multiply and FOIL with all those radicals. So what we're going to do is we're going to move one over to the other side. This one is negative, so I'm going to add it over to the other side. So now I have this, okay? Now you're thinking that's no better. Well, it's not a whole lot better, but when we square this side, we now do get rid of the radical. Unfortunately, on this side, we still have to square it, and you cannot distribute the squared still, so you have to go ahead and double distribute or FOIL or whatever you want to call this. You have to multiply all this out. So we're going to go through this carefully. 1 times 1 on a good day is just 1. Then we have 1 times this radical, which would be 4x plus 9. Okay. Then we have another one of those, plus 1 square root of 4x plus 9. And then we have the square root of 4x plus 9 times the square root of 4x plus 9, which is the square root of 4x plus 9 squared, or just 4x plus 9. This is where you have to know something about radicals, though. If you have one of these plus another one of these, you have 2 of those. So we have 1 plus 2 square roots of 4x plus 9, plus this squared and square root take care of each other. So this is what we're down to. You really need to get good at when you square a quantity, a binomial, you will get 2 of that middle term, okay? Real quick review. a plus b times a plus b turns out to be a squared plus 2ab plus b squared, okay? So that's the pattern we're looking for, and it'll take you a while, but you should be able to see that pattern eventually. All right, so this is where we are at. Still a mess, and still a radical in the problem. So we need to isolate this radical. So I'm going to do a little algebra maneuvering here. I'm going to subtract 4x from both sides. I'm also going to subtract 1 from both sides. And because I don't want to show so much work, I'm also going to subtract 9 from both sides. So this, and this, all in one step, will give us a 2x, 12 minus 1 is 11, minus 9 is 2. And over here we have a 2 times the quantity 4x plus 9. Now there's a little step we can do here that'll make life easier. We can divide everything by 2. Now over here, all it does is divide that out. And over here we end up with an x plus 1. So that was just to make our numbers smaller because they were all divisible by 2. Okay, now this is where it gets tricky because we have to square this again. This is really a pre-calc level problem, guys. So x plus 1 times x plus 1 is going to give us x squared plus a 1x plus another 1x, which would be 2x, plus a 1 times 1 is 1. Over here, if we square this, we just get a 4x plus 9. All right, now it's a quadratic, so I still need to get it equal to 0. If I subtract 4x and 9 over to this side, so that I have a 0 over here, I will get an x squared minus 2x minus 8 equals 0. Now we can factor. Are you having fun yet? X, let's see, factors of 8 that differ by 2 would be 4 and 2. Let's check if I have my signs right. X times x is x squared. Minus 4x plus 2x would be a minus 2x here. Negative 4 times 2 is negative 8. Okay, I factored right, so I get x equals 4 or x equals negative 2. There's a good chance those don't both work, okay, because we squared twice. So we have to go back to the very beginning and try both 4 and negative 2 in the original question. If I put a 4 in here, I would get 24 plus, whoa, that's not what you said, Hofbauer. I would get 24 plus 12, and in this one, when I put a 4 in, I will get 16 plus 9. This is the square root of 36 minus the square root of 25 equals 1. 6 minus 5 equals 1. We're good to go. All right, and there is no plus or minus. Remember, when you square root a number, it's always positive. If you square root an x squared, then you get a plus or minus. But this is working, we're good. The other one we got was negative 2, so we're going to have to go back and put in a negative 2. So when we put in, this was, by the way, we put in a 4, right? I didn't show that very clearly. 4 worked. So x equals 4 checked. All right, we put in a negative 2. This will become negative 12 plus 12. This will become, I'm putting in a 2, so negative 8 plus 9. This is the square root of 0, which is 0. This is the square root of 1, which is 1. But do you see what the problem is? Negative 1 does not equal 1. And that's most often what will happen is you get a negative doesn't equal a positive. Because when you squared somewhere along the line, you got an extra solution. So this was checking can x equal negative 2, and the answer was no. So the only solution we had in the end was that x equals 4. All right, if you're a little intimidated here, I will tell you that there's a possibility that you can check this answer by graphing. This is a lot of algebra and it's a lot of room for mistakes, but you should come up with at least one solution usually by the end. All right, I'm going to try this, show you on the calculator, square root of. I got to have that plot off. Square root of 6x plus 12. Was that what it was, guys? Arrow to the right. I think it was a minus. I had to go back to the problem here. Square root of 4x plus 9. All right, now we're trying to make this equal to 1, and I don't think we've practiced this much yet. I think I did it once on a problem where you wanted to know when something hit a height of 300. But if you want to know where this hits 1 exactly, what you want to do is put 1 into y2, and you want to find the intersection. Where does this equation equal 1? All right. I think we should be okay with a Zoom standard because I know ahead of time my answers were 4 and -2. And those are in the standard window, so I think we should be okay. Try Zoom 6. I can always change my window if it doesn't work. Though, not really that great of a window because I can't really tell, is it going to intersect again out here somewhere or something? I don't need all this y, and I mostly need more x. So I'm going to think about that. I needed less negative x. I needed to look further over maybe on the y, and I definitely didn't need so much, I'm sorry, on the positive x I needed more. I definitely didn't need so much y up and down. Okay, clearly only one solution. Second trace, I'm looking for the intersection point. Intersection is sweet because you can just go enter, 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 and it will find the intersection point. You don't really have to get very close unless there's more than one intersection point. All right, so we got 4. When x is 4, y will be 1. So putting a 4 in worked. All right, now, yes, you can solve this way, okay? Except when you get to calculus, you're going to have to be really good at all those algebra steps. So I would really suggest that you try practicing the algebra. I know it's a lot of steps, but I think I only assigned probably one that was that complicated. All right, this one looks complicated. This is number 5, and it is a little, but it's easier than the last one by far. If you square the left, you just get x minus 15. If you square the right, you have to multiply it by itself. That's what squaring means, and because it's a binomial with a minus in the middle, we're going to have to FOIL this out, but it's not so bad. 3 times 3 is 9. We get a -3 square roots of x and another -3 square roots of x. And then a negative times a negative here would be a positive, and the square root of x squared is just going to be x. So we have x minus 15 equals 9. These are like terms. There's -6 square roots of x. Square root of x squared is just x. Now, if I try, whoops, there's a plus in there, sorry. If I try to isolate this quantity right here, if I subtract an x, subtract a 9, this number is multiplied, so we have to divide it off. I get 4 equals a square root of x. If I square both sides again, I get 16 equals x. And then we need to plug it back in to check. So does x equal 16 is our question. 16 minus 15 is the square root of 1. On the other side, originally we had 3 minus the square root of, and over here we'd have 3 minus the square root of 16 is 4. And the square root of 1 is positive 1. Does 1 equal 3 minus 4? The answer is no, because 3 minus 4 is -1. So these are not equal. So x cannot equal 16. And that was the only solution we found, so this one has no solution, which means if we graph this, they are never going to intersect. I guess I can take a second to show you what that would look like. So we'd have the square root of x minus 15. And down here, whoa. We would have 3 minus the square root of x. And when we graphed them, I don't think this is going to fit in this window, because this is a square root graph shifted to the right 15. Actually, it might, because we changed our window to 20. All right, so I'm going to graph. And this is what it looks like. One is starting here and opening down, and one is over here at 15 and opening up. So if you had used a standard window, you wouldn't have seen that one at all. And you would have had to use your transformation brain to realize this had shifted to the right 15. So to the right 15 means I need my x max to be a whole lot more. I could even make that really long. And there, they're never going to intersect, okay? So we got no solution. All right, I'm going to do one more of these messy algebraic ones. Square this side and square this side, which means multiply by itself. The left-hand side just becomes x plus 6. Over here I have to FOIL. 5 times 5 is 25. 5 times a negative square root of x plus 1. Another 5 times a negative square root of x plus 1. And then a negative times a negative is a positive, and it is the square root of x plus 1 squared, or just x plus 1. That's how I usually just write it. Now, these two combine, negative 5 minus 5 more is negative 10. We had a 25 out here and an x plus 6. I usually skip this step right here and go right to this one, but that's experience with algebra. Feel free to write it all out. Now look what happens if I subtract an x from both sides. Those are gone. I have a 1 and 25 over here. I'm going to subtract them both over here. That's negative 26 is negative 20. 6 minus 1 is 5. Minus 25 is negative 20. However you want to do it, take your time. Do it in 2 steps. It doesn't matter. Now we're going to divide both sides by negative 10. We get 2 equals square root of x plus 1. We do have to square again, but it's much nicer this time. So we just get 4 equals x plus 1. We subtract and we get 3. Now we need to check it. If I put a 3 back in here, I'm checking is x equal to 3. I get the square root of 3 plus 6 is 9. 5 minus the square root of 3 plus 1, which would be 4. This is 3. This is 5. This is 2. And 5 minus 2 is 3. So yes, x equals 3 will work. If you graphed this left-hand side in y1, the right-hand side in y2, they would intersect when x is 3. All right, that's the lesson on square root solving radicals equations, okay? This is not about graphing, this is about solving radical equations. Short practice worksheet. Good luck.